Hello everyone and welcome back. Today we will know how to calculate the atomic radius, and we will also talk about the atomic radius trends in periodic table. So first of all, we all know that the atom consists of nucleus that carries positively charged protons and neutrally charged neutrons. Around this nucleus there are electrons that rotate around my nucleus. They carry a negative charge and they occupy the region around my nucleus. If I needed to calculate the atomic radius should be the distance between the nucleus and my electrons, or the farthest electron in my atom. Now, according to the modern atomic theory, the electron occupies a certain region around my nucleus, so it is hard to calculate the atomic radius according to the modern atomic theory. For that, we use another method. So you could see from here, we can just calculate the atomic radius indirectly by measuring the distance between two nuclei, and half of this distance would be my radius. So R for that would be equal to D, the distance between two nuclei from the same element, over 2. Now, if I looked at the periodic table, you could see that we have 18 groups, and from top to down we have seven periods. Those are the metals, and here we have the non-metals, and those orange-colored elements are my metalloids. The actinide and the lanthanides and the actinides, we put them down the periodic table in order to squeeze my periodic table. Now, if I move from left to right, you could see that in here I have 19, in here I have 20, 21. So I'm increasing the atomic number. When I'm increasing the atomic number, I'm increasing the number of the electron within the same level. So I'm just adding more electrons within the same level. While moving from top to down, I'm increasing the number of my levels. So the first one, I have this first level. The second period, I have the second level. The third, I have the third level, and moving until I have 7 levels. So in here, you could see I'm increasing the size of my atom. While moving from left to right, I'm just increasing the number of the electrons within the same level, which will create a strong attraction between my nucleus and the electrons. You could see for group 1A, you have the lithium with the atomic radius 1.5 angstrom. You have to remember that angstrom is equal to 1 multiplied by 10 to the power minus 10 meter. Now moving to the sodium, you have the radius increased a little bit more because I'm increasing the levels by 1 level. But what about across? So moving from top to down, I'm increasing the atomic radius. But look at the second period, and let's compare the atomic size, and you could see moving from lithium up to oxygen, what happens is actually you are increasing the atomic number where you are still in the same atomic level or atomic shell. This is why your atomic size is actually decreasing across your period. So moving from left to right, you are decreasing the atomic radius because you are increasing the attraction between the electrons and the nucleus, and you are not adding any extra levels to move away the electrons from the attraction of your nucleus. So a summary for that, if I looked at across my period from left to right, from one group to the other, I'm decreasing the atomic radius because I'm adding. But if I moved in the same group, you could see that I'm increasing the number of levels. This is why I'm increasing the atomic radius. By that, we came to the end of our video. Thank you and goodbye.